Hello everyone. In this episode, I'm going to demonstrate how to draw a free body diagram in statics. I'm only going to cover problems in 2 dimensions. I believe if you can fully understand the basics, you can just learn more difficult contents like 3-dimensional case by yourself. So my role here is to teach you how to walk before you can fly. You will see 3 things in free body diagram: the body, some forces, and alphabets that represent forces. In real practices, you may need to draw several free body diagrams to solve one problem, but you always start with the body in the figure provided by the problem. I call them the main body and the main free body diagram. The rest of the free body diagrams are constructed from some partial components of the main body when they are necessary for solving the problems. I call them the section free body diagrams, and I'll talk about it later in the example. But now, let's just focus on main free body diagram. We start with the main body first. The main body in the free body diagram refers to anything that is inside of an imaginary boundary. Forces presented inside of the boundary are internal forces, and you should not include them in the free body diagram. But how exactly do we know where the boundary is? At this point, I should just say use the supports to separate the main body from the surroundings. Any parts of the body that contact the supports are the boundaries. But since boundary has no exact form, I will demonstrate how to identify it in the examples later. The forces that do need to include in the free body diagram are external forces. There are 2 types of external forces. The first type is reactive force. Remember, where there are supports, there are reactive forces. So if you can find all the supports, you are halfway done. Now, I'm going to show you different types of supports that you will see in the statics problem. Number 1, smooth surface. The reactive force on smooth surface is normal force. Number 2, an edge. Usually, you will see the body with a smooth surface leaning against the edge. The reactive force is normal force. However, it is perpendicular to the surface of the body. Number 3, rope, cable, and wire. These supports are only in tension, so the force is along the cable. Number 4, spring. The reactive force is pull if the spring is in tension, and is push if the spring is in compression. Number 5, link. This situation is the same as it is in spring case. If the problem doesn't specify that the link is either in tension or in compression, just draw the arrow in either direction along the link. We will determine the true direction based on the sign of the force calculated from equilibrium conditions later. Number 6, roller. The reactive force is normal force, perpendicular to the surface, supporting the roller. Notice that there is only one reactive force presented in the previous supports. The next few supports are going to have multiple reactive forces. Number 7, rough surface. There are 2 reactive forces. One is normal force perpendicular to the surface. The other is friction, parallel to the surface. Number 8, pin or hinge. There are 2 reactive forces which are along x and y axis. Number 9, fixed. There are 2 reactive forces the same as they are in the pin or hinge case. And there is one moment about z-axis. At this point, just draw a circular arrow in counterclockwise direction to represent the moment. We will handle it later when I introduce equilibrium conditions in the future episode. One thing I want to add is that these reactive forces are unknown. Free body diagram helps us see these unknown forces, which will be determined by equilibrium conditions. That's why it's super important that you know how to draw a free body diagram. The second type of external forces is applied force. You do not need to find them because they are given by the problems. However, some problems want you to take the weight of the body into consideration, so you will need to add the weight as applied force. Lastly, but not the least, let me summarize the general procedure to construct a free body diagram. Step 1. Identify all the supports. Step 2. Identify the boundary and the body. Step 3. Draw reactive forces. Step 4. Draw applied forces. That's it. Only 4 steps. Not too bad. Now, let's apply these 4 steps to some problems and see if you are fully understood. Example 1. Step 1. Identify all the supports. In the diagram, I see a smooth surface and a cable. Step 2. Identify the boundary and the body. The boundary is always enclosed by the supports, and in this case is indicated as shown, and the body is the ball. Step 3. Draw reactive forces. Based on the supports identified, we have normal force on the smooth surface and a tension in the cable. Step 4. Draw applied force. In this case, the weight of the ball is the only applied force. And free body diagram is finished. I know this is too easy, so let's practice a harder problem. Here we have a real truss problem in statics. The problem wants me to determine the forces in member AH, HG, and BG. Here are the basic steps to solve this problem. Draw the main free body diagram for the entire truss. Find the reaction forces at support A and B. Draw section free body diagram and find the force in member AH. And draw another section free body diagram, then find the forces in member HG and BG. In the future episode, I will talk about how to calculate reaction forces and so on, but here, I'm only going to focus on free body diagram. Now let's apply the 4-step method I introduced. Step 1. Identify all the supports. In the diagram, I see a pin support and a roller support. Be careful, the pin at the points C, D, E, F, G, H are not supports. Therefore, there is no reactive force there. Step 2. Identify the boundaries and body. Since I know I need to draw main free body diagram first, the boundary will be indicated as shown, and the body is the entire truss members. Step 3. Draw reactive forces. Based on the supports identified, there are 2 reactive forces at pin A, and a normal force at roller B. Step 4. Draw applied force. Usually, weight is negligible in truss problems, so applied forces here are just 1 kilonewton at E and 15 kilonewton at D. And they are given by the problem. So we are finished. Now let's see how to draw section free body diagram. The purpose of drawing section free body diagram is to turn the internal forces in the members into external forces and use equilibrium conditions to determine the forces. I want to determine the force in member AH, so I need to re-identify the boundary and the body so that I can make the force AH visible in free body diagram. Let's follow the 4-step method again. Step 1. Identify all the supports. Since we did it already, we can skip it. Step 2. Identify the boundary and the body. Step 3. Draw reactive forces. In main free body diagram, we already identified reactive forces at pin A and assume we have calculated the value of AX and AY. reactive force at roller B is not contained in the body, so I don't draw it in this section free body diagram. However, forces in the member become external forces as PAH and PAB. Step 4. Draw applied force. I don't see any applied forces in the boundary, so we are finished. Finally, to determine forces in HG and BG, we take the same steps again. Step 1. Identify all the supports, since we did it already, so we can skip it. Step 2. Identify the boundary and body. Keep in mind that I want to determine forces in HG and BG, so I need to make those forces become external forces. Step 3. Draw reactive forces. We already identified reactive forces at pin A, and this time roller B is also contained in the boundary. Forces in the members that are on the boundary become external forces as PHG, PBG, and PBC. Step 4. Draw applied force. Again, there is no applied force in the boundary, so we are done. As you can see, no matter what problems you're doing, just follow the 4-step method and you can draw the free body diagram in seconds without a mistake. Alright, this is all I have for you guys today. So if you like the video, please subscribe my channel and like the video. I promise I will make more videos like this in the future. I believe I will talk about equilibrium conditions in the next video. Have a good statics day.